Hey guys, this is Carrie, and this is the answer key for homework number 3. So just like in the do now, we're supposed to identify what types of numbers these are, rational, irrational, or not a number, and do some things with it. So square root of 7, because 7 isn't a perfect square, this is an irrational number. We've got 5 square root of negative 64. And so thinking about square roots, right, when you find the square root of a number, you're thinking what number times itself will give you negative 64. And you might think, well, maybe 8 times 8 would work, but that's positive 64. So maybe if you make them both negative, but that's also positive 64. So maybe if one's positive and one's negative, but for a square root, they actually have to be the same number. And so testing all these possibilities shows that there's no number that will make negative 64 when you multiply it by itself.
Next week.
So this is actually not a number. Next up, we've got negative 5 square root of 64. The square root of 64 is 8 because 8 times 8 is 64. So we get negative 5 times 8, which is negative 40. Square root of 1 is 1, and square root of 0 is 0, just like we saw in class. All three of these are rational numbers. For problem 2, let f of x equal that and g of x equal that. For what values of x does f of x equal g of x? So because we want f of x to equal g of x, we can use their equations or their expressions, square root of 20 minus x squared, to equal the expression for g of x, negative 2x. From here, all we have to do is solve for x. So square both sides to cancel out the square root. We get 20 minus x squared is equal to, and this side I think is the one we really have been working hard on in classes, just make sure you square the whole side, put it in parentheses. Negative 2 squared is 4, x squared is x squared. We add x squared to both sides. That gives us 20 equals 5x squared. Divide by 5 on both sides. X squared is equal to 4. Take the square root of both sides, and because the exponent is 2, we expect 2 solutions. So x equals 2 or x equals negative 2. Now remember with square roots, whenever you have a square root in the start of the problem, checking your answer is not an option. It's actually part of getting the final answer. So it's not that we're checking our answer to make sure we got it right. We're checking our answer because it's a necessary part of the problem in order to make sure we get the right solution. So let's check x equals 2 first. So checking x equals 2 means we plug 2 in to the original equation. So square root of 20 minus 2 squared equals negative 2 times 2. I like to put a question mark here just because I don't know that these are equal. 2 squared is 4. 20 minus 4 is 16. So square root of 16 equals negative 4. That's not true. Square root of 16 is positive 4. So 2 is an extraneous solution. Next, we need to check x equals negative 2 because it's possible that they're both actually extraneous solutions. So we get 20 minus negative 2 squared, all in a square root, equals negative 2 times negative 2. 20 minus 4 square root, that's square root of 16. This is equal to 4, this is equal to 4, and square root of 16 is 4, so that works out. X equals negative 2 is a solution, so we're good to go. For problem 3, if f of x is equal to the square root of x minus 4 plus 3, then determine f inverse of x. So just like we did in class today, there are 4 steps for finding an inverse function. Step 1, make f of x equal to y. So we end up, I should show my steps over here off to the side. So y is equal to the square root of x minus 4 plus 3. Step 2, in order for this to be the inverse, we have to switch the input and output. So switch x and y. That gives us x equals the square root of y minus 4 plus 3. This equation looks a little strange because y hasn't been isolated, but in step 3 we'll address that because step 3 is to isolate y. So I'm going to, I'll just leave it like this. Minus 3 on both sides. We get x minus 3 is equal to the square root of y minus 4. Square both sides, and you get y minus 4 on this side. And on this side, just like we talked about in class, when you square something, you're squaring that whole side, which means you have x minus 3 times itself. And I think this is going to be the hardest step to remember to do. So whenever you square something, it means that thing times itself. Because this is a binomial times a binomial, we need to distribute. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. So you get all of that equals y minus 4. Last step to isolate y is to add 4 on both sides and combine like terms. So we have y is equal to x squared minus 6x plus 13. Finally, we made up the variable y, so we need to go back to the variables from the problem. So change y to f inverse of x. So we get f inverse of x is equal to x squared minus 6x plus 13. All right, next up, which of the following is the graph of g of x equals the square root of x minus 3 plus 5? So I want to go through these a little bit slower because we didn't have that much time to talk about them in class. So whenever you're looking at the graph of a square root, you can think about the most basic square root graph would be f of x equals the square root of x. We know that that graph is going to be a square root curve starting at the origin. So what we're really thinking about in this problem is how will this minus 3 and this plus 5 change our graph? So because minus 3 is inside of the square root with the x, minus 3 is an inside transformation. Inside transformations will always move the graph in the x direction in the opposite way than you expect. So you might think, well, x direction is left and right. Negative 3 seems like you should be moving to the left, but because this is an inside transformation, it's the opposite of what you expect, so it results in right 3. For 5, because 5 is outside of the square root, this is an outside transformation. So this is going to move our graph in the y direction. And outside transformations are friendly. They move you in the direction that you expect to move, so this will move us up 5. So in order to pick out the right graph, we're looking for a graph that moves the square root function right 3 and up 5, so that it starts here and then loops. So it's not going to be answer choice 1, it's not going to be answer choice 2, it's not going to be answer choice 3. It has to be answer choice 4 because we moved right 3 and up 5. On the grid below, draw rough sketches of each of the following functions. Make sure to label the vertex with its coordinates. So I like to think about the most basic square root of x graph, which starts at the origin and moves up. So this graph, just like last time, has two transformations. An inside transformation. Inside will move us in the x direction in the opposite way than we expect. So you might think plus 4 should be right, but it actually results in left 4. So we're going to go left 4. We have an outside transformation, so we'll go up. Oh, not up, right? It's negative 1. So, sorry, school day is ending, so I'm just trying to find a quiet space. So outside is going to be in the y direction, and that will be down 1. So that results in our graph being here. All right, next up, just hold on 1 second, sorry. Trying to find a quiet room. Hey.
Wow, so you ain't up on do a trick, bro.
Yeah, that's totally fine. Did you figure out how I can copy
I'm
and
on
paste
video,
it?
sorry.
What?
I'm on video.
Oh.
Sorry. So f of x is equal to x minus 5 plus 2. So this is an inside transformation. So this will move us in the x direction, opposite of what we expect. So you might think that minus 5 is back 5. But since it's the opposite of what we expect, minus 5 moves us right 5. Then we've got an outside transformation of plus 2. So outside transformations will always affect the y direction. These are in the direction we expect, so this should be up 2. So if you start with the square root of x graph here, then our graph is going to be the exact same shape, but moved 5 to the right, because it was minus 5, and up 2. So here. And I'm actually noticing that my work here is pretty poorly shown. I think I got distracted with the end of the school day. So I should be actually adding tick marks for my graphs. So let me do that now. This graph should have been back 4, so 1, 2, 3, 4, and I should label that -4. And then down 1, so I should label this -1. And to be extra clear, I can label the vertex -4, -1. For this graph here, I should actually draw tick marks 1, 2, 3, 4, 5. And then up 2 should have 2 tick marks, and I should label my vertex 5, 2. Okay, that looks complete. Specify the domain and range of this function. So I think the easiest way to do this is to draw a rough sketch. So I'm going to think about a regular square root graph. That will be here. So in order to graph this function instead, let me graph this one in green. We'll be moving inside transformation. So it will affect the x direction, opposite of what we expect. So it'll be right 7. So 1, 2, 3, 4, 5, 6, 7. And then we've got an outside transformation that's +3. So this will move us up 1, 2, 3. Oops, I should actually write down what I just said. Outside always affects y, but in the direction that you expect, so up 3. So now we've got our new graph right here. So lastly, we need to find the domain and range of this graph. So the domain is the set of x values that are included. So we have all the x values that start at 7, and we actually can equal 7. And our x values go to infinity, so all the x values that are less than infinity. Now, just like we said in class, you don't have to write less than infinity. Everything is less than infinity. So the domain for final answer will be x is greater than or equal to 7. Next up for the range is going to be the same thing but for the y values. So the lowest y value that appears is 3. So 3 is less than all of the y values on the graph. And because this graph keeps going up forever, all of these y values are less than infinity. Lastly, y can equal 3. And this idea of y being less than infinity is kind of extra, right? Everything is less than infinity. That's sort of its definition. So we don't need to include that it's less than infinity. So we end up with y is greater than or equal to 3. That's our final answer. So I hope that was clear despite the disruption in the hallway. I mean, it's the end of the school day, I guess, and next time I'll try to